Today we're going to work on solving word problems. We're going to be solving multi-step word problems using the cubes method. This will be a review of work we were doing prior, and just a good way to solve word problems and be able to pull information out of the text when necessary, being able to understand which problem is being solved, and being able to create algebraic expressions by using the data within the text. So as I mentioned, we're going to be using what's known as the cubes method. The cubes method is a great way to pull things out, identify them, and place them into order, as well as into basis of necessity, as we'll learn. So the first step in cubes is the C, of course. It's to circle all key numbers and units, find out, what do I know? What are they telling me within this text? What information is right there already? In this instance, because I do not have the capability to circle as of yet, I will be making the numbers into a color red, much like the C you see on your left. Next, we're going to underline the question. What is it I'm being asked to solve? So when we go through the problem, the question, they may say this and this and this and this, but we want to know exactly what it is that we have to solve from the data that we've gathered. Next, we're going to box or bold the math clue words, which will give us an inkling as to the operation we'll be using. So am I going to be using addition, subtraction, multiplication, or division? Will I be using greater than or less than? Will I be using a percentage? Will I be looking for a ratio? So all of those things will be within the text. We need to make sure we're boxing, bolding them, blocking them. In this instance, I'm going to bold them. And as you'll see, they've already been done. I want you all to get into this practice as well. Next, we're going to evaluate and eliminate. So what steps do I take? Again, back to the operation. And what information do I not need, as well as what information do I need? So we've gotten the key numbers. We've underlined the question. We've bolded the clue words. What don't I need here? What do I need? What numbers are irrelevant? What operations are irrelevant? What do I need? Finally, we're going to solve and show our work. Does my answer make sense, and how can I double check? Showing your work simply involves going over the steps that we will show here and that we've already been working on, as well as going back and plugging in to make sure your answer makes sense afterwards, which is the double checking aspect of it. Double check. So our first example is going to be, Allie bought 6 packages of cat food and 5 packages of dog food. Each package of cat food contained 8 cans, and each package of dog food contained 2 cans. How many more cans of cat food than dog food did Allie buy? So the first thing we want to do is go through our cubes. I've already done it, so I've colored red the numbers. I've underlined the question. I've blocked and bolded the operation, which will be subtraction after multiplication, and I've eliminated unnecessary information. In this instance, all of the information will be necessary, so there's nothing to be eliminated. Next thing we want to do is create an algebraic expression using the information. We're going to use C for cat food and D for dog food. Using those, in order to figure out how much of each we have, we're going to do 6C, which is the amount of cans of cat food within each package, and 5D, which is the amount of cans in each package of dog food. And we're looking for the difference between the two. How many more? Right there. How many more? So we're going to plug in the numbers that we have for the variables, which will be, in the case of the cat food, it will be 8, and in dog food, it will be 2. That's the amount of cans contained in each package. So there were 8 cans in each package of cat food and 2 in each package of dog food. So that gives us the expression 6 times 8 minus 5 times 2. We're going to use our order of operations, PEMDAS, to evaluate the expression. So we have 6 times 8 minus 5 times 2. We know we do what's in the parentheses first and the multiplication. So we're going to come up with 48 minus 10, which gives us a difference of 38. So the answer is, Allie bought 38 more cans of cat food than dog food. The next example we're going to do is a addition problem, but it has information that will lead us to finding our variables. So the first bit of information is that there are 3 pens in Kendrick's desk drawer. There are 10 more black pens than red pens. There are also 6 more blue pens than red pens. How many pens are there in all? So we want to do our cubes method. As you can see, I've already colored red the numbers. We've got 3, 10, and 6. I've already underlined the question, how many pens are there in all? I've bolded out the math terms, more than, and the last one is in all. All information is necessary, no need to evaluate. Next, we're going to create an algebraic expression for the problem using R for red pens, B for black pens, and L for blue pens. We are solving for in all, which is addition, which will give us R plus B plus L. We're going to plug in our variables with the information we know. We know that R equals 3 and that B equals R plus 10 and L equals R plus 6. So we're going to make B 3 plus 10 and L 3 plus 6, which will give us a value of 13 for B and 9 for L. Now we plug in to get in all, we must add the red pens because we're solving for R plus B plus L or R plus L plus B. So we get 3 plus 9 plus 13, which gives us a sum of 25. I hope you all enjoyed the video. Have a great rest of the day. See you soon.